Hi and welcome to MSc. In this video we're going to look at factoring by decomposition. So factoring by decomposition is a way of factoring trinomials that can work sometimes when we don't have trinomials that we can common factor down to a coefficient where the coefficient in front of x squared would be 1. So notice we have coefficients in front of the x squared in both of these examples that we'll work through. And in both cases, we can't common factor that value out of the other coefficients that we see, the other numbers. So 2 will not easily common factor out of 11 and 21, and nor will 3 out of 10 and 8. Keep in mind, please, that there are trinomials that are not easily factorable over the integers or over reasonable fractions. They will involve radicals, and this method would not be appropriate for those. What we're looking at here, because the first step we always try is to common factor, and we can't. So that means the regular trinomial factoring, where we look for numbers that multiply to the last term and add to the middle term coefficient, isn't going to work here. And instead what we look at is we look at taking the product of the 2 and the 21. So we're going to do 2 times, and it's negative 21, and that's going to give us negative 42. So now what we're trying to do is we're actually trying to get numbers that will multiply to negative 42 and that will add to the negative 11. So we're still adding to that middle term, but we're now not trying to multiply to 21, but to twice 21. And again, I fully encourage students to list out factors if that's helpful to them. 1 and 42 isn't going to do much for us. We could look at 2 and 21. We know that the bigger number is going to have to be negative here because it's still going to generate a negative sum, and one of them has to be negative because we have the negative product that was going to generate. So if that doesn't have a difference of 11, I could now look at 3 times 14, well, that has a difference of 11. So now I know it's negative 14 and positive 3, and I know it's the negative 14 because I need to add to negative 11. So now I have two numbers, but what we do here is different than what we've seen in the past, where we set up straight to the brackets. So what we're going to do is we're going to write our 2x squared still, and now I'm decomposing. That's why I call this factor by decomposition. We're decomposing this negative 11 into 3x and negative 14x. And so the order here does matter in terms of where we place them. We have to be a little bit more strategic and smart about it. So when I look at 3 and 2, I don't see anything that can factor out of the 3 and 2, but the 14 and the 2 I do. So I'm actually going to say this is negative 14x, and then I'm going to say plus 3x minus 21. And notice that there is a common factor then between 3 and the negative 21. So again, really mathematically, the order of these two terms that we're putting in don't matter, but I always try to strategically put things here and here that are factorable by common factoring, and then here and here that are factorable by common factoring. So what we've done here is we've taken this negative 11, and we've negative 11x really, and we've decomposed it into the two parts. So now the next step of this is to take a look at the first two terms and common factor everything we can out, x included. So in the first two terms, I can common factor out 2x. That leaves me with x behind, because 2x times x is 2x squared, and it will leave me with negative 7. 2x times negative 7 is negative 14. So we have that part. Then I look at the next two terms. And out of the next two terms, I can't common factor an x, but I can common factor a 3. So we'll say plus 3, and then we'll do bracket x minus 7, close bracket. So first two terms, we were able to take a 2x out, and if I redistributed this back in, I'd get those two terms. Here I was able to take a 3 out, and if I redistributed the 3, I'd get the last two terms. Again, we have not changed the value of this overall quadratic equation. Now what I see is I see the first term here that has a bracket piece and a second term. But the bracket pieces in both cases are identical. So what I can now do is I can common factor out whatever is in these brackets. And you'll know you're doing this properly if what's left in the brackets in both cases is the same. That's what we're looking for. So what I write is that bracket piece. And what did I common factor it from? Well, out of the first term here is 2x. And out of the second term is 3. Okay? And we can redistribute this. If I redistributed this back in, I'd get 2x times x minus 7, which we have, and I'd get 3 times x minus 7, which we have here. So this is now factored form of this standard form function that was originally given to us. And again, you can check this using technology. We could also try redistributing and recollecting, and we'd get the same answer. So these are always somewhat checkable in that regards. Again, factored form then allows us to solve for the zeros of the function, solve for the roots. So for example here, when we're solving for the roots, we're setting y equals to 0. And I want to show you this process because this looks a little different because we have a 2 in front of the x here when we're solving for these zeros. So this statement can be true when either this first bracket is 0, so when x minus 7 equals 0, which is true when x equals 7, or it's true when this bracket is 0. And that will be 2x equals negative 3 by moving the 3 across, and then divide both sides by 2. You'll get x equals negative 3/2. And so you'll always end up with this fraction as one of your x-intercepts using this method. And again, this method is really only suitable when we have x-intercepts that are of that style. Let's look at this other example, and I'll go a little bit quicker through it because we've already seen this process once. I fully encourage you to pause the video and then run through it with me after to see if you got it right. So I can't common factor this 3 out of everything, but I'm going to try factoring by decomposition. So 3 times negative 8, so 3 times the negative 8, this is going to give me negative 24. So I'm looking for numbers that will multiply to produce 24 and will add to produce the middle term, just like simple trinomial factoring. We're going to list out some factors here that we're going to try. 1 and 24 won't do it, but 2 and 12 might. So 2 and 12 have the benefit here of having a difference of 10. We know one of them is negative, and we know the bigger one's negative. So it's going to be negative 12 and 2. Okay, so those are the pieces. That's what I'm going to break this 10 into. I'm going to break it into negative 12 and 2. So then we can work here, and we're going to decompose that middle term. Again, I'm going to be smart with which one I put first. I'm going to put the negative 12 first because 3 goes into 12. 3 and 2, there's no common factors there. So I'm going to rewrite this as negative 12, and I'm not going to forget the x because it's important, and then plus 2x minus 8. So we have decomposed that negative 10, and I've chosen ways of doing that that are going to allow me to do other factoring. Looking at the first two terms now, I'm going to factor out everything I can, including x's. So this is 3x, and that's going to leave me with x minus 4. Now I'm expecting now that I'll get x minus 4 as the bracket piece on the other factoring that we do. Let's see. So this is going to be plus, and I'm looking to factor out a 2 out of both of these. If I was common factoring out a negative piece out of both, then this would become a negative down below. So it's going to be 2, and that's going to leave me with x minus 4. Excellent. So those bracket parts are the same. And now I'm going to write that bracket part that we found that are common to both of these terms now. And I'm common factoring it out of both. And that's going to leave me with a 3x and a positive 2. And you can see from doing this that we're going to get roots of positive 4 and a root of negative 2/3. And I'll let you solve that much like you did down here if that's what the question was asking you to do. Right now we've just been asked really just to factor. So factoring by decomposition is a good alternative to try, especially if you've been asked to factor it, and presumably it is factorable over reasonable numbers. And it will result in some fractions, but it will allow you to factor things that in the past you might not have been able to do, or might have had to do with more trial and error than you'd care to do. Thank you very much for listening to this video. I hope it's been helpful. Please consider liking the video and subscribing to the channel. Thank you for listening and watching.